In this section 7.7, I'll explain more about method. As we have discussed, high-level design issues include identifying primary classes and objects, assigning primary responsibilities. After establishing high-level design issues, it is important to address low-level issues such as the design of key methods. For some methods, careful planning is needed to make sure they contribute to an efficient and elegant system design. So, I will explain by example about the method design. This is the code to compute factorial. You know what factorial is. And factorial is like this. N times n-1 times n-2 times 3 to 1, like this. Okay, so this is the code for factorial. And factorial is computed inside main. There is only one method, that is main. So inside main, we input one number, and that is the number we want to calculate factorial value. So this is the code for computing factorial. So result is n, and from n to 1. From n to 1, a is multiplied to result. So result will have the factorial value, right? So after this calculation, the result is printed out like this. So this is the input part. Input for the calculation, and this is the result of the output of the n factorial, right? And this is the core part of the calculation of n factorial. Okay, so if we want to divide this part into a method, then we can make this part. We can make this part as a factorial method. In writing a method, the important thing is that you must think about what should be the parameter for the method, and what is the output, what is the result of the method. Okay. Because if you make a method, if you want to make a method, return type and method name, and important thing is the parameters. In the parentheses, there is a parameters. These are important. So you must write method like this. So this parameter should be the input. Should be the input for the method. Should be the input for the method. And this method will do something with this input. And then finally, this method will have a result. Sometimes the method doesn't have a result, but most of the time method will have a result. So the method will find one result. Then this should be the type of this result, right? You already know that. So this method will do something with this input, and then have one result. It should have one result, and then return it to the place where the method is called. Okay, so here we have input for the factorial value, and here is the output for the factorial value, and this is the part for actual computation of factorial. So I will make this part as a method, separate method, and this method will have n is an input to this method, and then result will be the output of this method. Okay, so I will make a factorial method based on what I'm explaining right now. So I'll show that. This is a factorial method. Here m is the output, and answer is m is the input, and answer is the output. So in main, at first read one input from the user, and the input, that input will be goes into the factorial method like this. And then m has the same value as n, right? So m will copy the value of n and then find m factorial here, m factorial, then return answer. Then answer will be returned here, and then result will have that answer. Okay. Actually, we studied this factorial method code in chapter 5 when learning while loop. So I hope all of you understand this one. So if you want to write a code using a method, you must think about what should be the input of the method. Okay, so this time n is the input, and then what should be the output of this method? Then you must have the result. The result of the method should be returned to the place where the method is called. Okay, and then finally the method result will be assigned to this variable. Okay, so as you see here, there is no factorial code. Okay, there is no factorial code, only they call factorial method. Then factorial method will do everything for computing factorial. Okay, so if you want to write a method, then you must think about input, output. Okay, so this is very simple but important example for writing a method. Here is a Fibonacci method without using a method. So in the main, everything is in the main. So at first, read one input, and then find Fibonacci value of that input, and finally print out the output. So in this example, I assume that first input is 1 as output is 1. If 2 is input and the output is 1. So at first these two values should be given to compute Fibonacci value, and the third value will be calculated by adding the previous two values, right? So by adding these two values, we can have next Fibonacci value. And likewise, if we add two numbers, then this will give the next Fibonacci number. Okay, and add these two numbers, then this will be the next Fibonacci number. Okay, so the formula is for a Fibonacci number is adding the previous two values. So first is 1 and second is 1 should be given. And then read one input. So input should be one of these numbers. Okay. And if the input is 12, then output should be 144. Okay. So at first, when you write a method, you must completely know what the input is and what the output is. So here, n is read by the user and compute Fibonacci value and then print out the output. So I'm going to write this part as a method by having this input as the input of the Fibonacci number, and then have the output is the output of the Fibonacci number. Okay. This is a Fibonacci method. I think you have already known this one because I have explained this code in chapter 5. But I explain one more time here. This is a Fibonacci method like this. Okay, and then this is the main method. Main method will call Fibonacci method. Here, at first, main method will read one input from the user. And then this input value will be go into the parameter to this is the form actual parameter, right? So actual parameter for Fibonacci method. Then here Fibonacci method will be called. So the program control goes to Fibonacci method. So this input number will be copied to this in parameter. Then Fibonacci will be calculated like this, and then the final result will be returned to the place where Fibonacci is called, right? So the return value will be here, and then it will be assigned to output, right? So as you see here, there is no Fibonacci code in the main. The duty of main is only have input, okay? Having input and just put pass the input to the Fibonacci method. Then Fibonacci method will do everything. Will do everything to compute a Fibonacci value and then return the result. Okay, so if you want to design a method, you must think about input and output. Okay, and then every actual computation should be done in the method, inside the method. Now, prime number method. We also have seen this one. So we receive one input and then we will check that input is prime or not. That was the problem. So I explained this one. If we want to check the number is prime or not, then if the number has only two factors, 1 and the number itself, then it is the prime number, right? So 7 is the prime number, but 8 is not, because 8 has 4 factors, 1, 2, 4, 8. Okay, so while looping from 1 to that number, we will check how many factors are there. Okay, so I used this idea to find out the number is prime or not. This is code for the prime. At first, the computer will receive one input like this, and then compute the number of factors of that input. Okay, so compute the number of factors of that input. If it is 2, if the number of factors is 2, then input number is a prime. If that is not the case, then the number is not a prime. Okay, I think you know the details of the code. So I will separate this part. This is the part for checking for prime. So I will separate this part as a method. This time also the input is the input for the method. Okay, and then the method will return true or false. If input is a prime number, then the method will return true. If it is not, then it will return false. Okay, so the method will have return type as Boolean. Okay, Boolean return type. I'll show that. So in main, this is a prime with the method. So in main, we will receive one input. Then this input will go into the parameter as a parameter to is prime method. Okay, since the result is true or false, in that case we used to make name like this, is prime, then return is true or false. Okay, so is prime method will return true or false, so the result will have Boolean type, should be the Boolean type. Okay, so in the is prime method, is prime will receive one input, integer, and then count the number of factors of n. And if the number of factors is 2, then return true. Otherwise, return false. Okay, so return type is Boolean. Return is Boolean. So after receiving the result, if the result is false, then prime number is printed out. Otherwise, if the result is false, then not a prime number is printed out. Okay, and actually you can write like this. This part, you can write if. You don't have to write true. So if, and then if you can write result like this, just result like this. Okay, this is also okay. Okay, because if you write like this, then if this is true, then if true, So computer will execute the if part. Okay. So if you want, you can write like this, but if you can think this is more neat, then you can write like this. I'll explain method decomposition. This is from the textbook. A method should be relatively small so that it can be understood as a single entity. As we've seen before, the method is for factorial, only for factorial. Okay, this is for only for Fibonacci, only for prime number, something like that. A potentially large method should be decomposed into several smaller methods as needed for clarity. Okay, you should write methods very clearly. A public service method of an object may call one or more private support methods to help it accomplish its goal. Support methods might call other support methods if appropriate. Okay, we will understand this one by seeing other example. Let's look at an example that requires method decomposition, translating English into Pig Latin. Pig Latin is a language in which each word is modified by moving the initial sound of the word to the end and adding ay. So for example, book is an English word, and the first letter B should be moved to the end of the letter, the end of the word. So OOK is left like this, and the first letter B is added to the end. Okay, and then adding AY. So this is a Pig Latin word. Likewise, table. T is moved to the last part of the word. So A, B, L, E, T, and A, Y is added. Okay. Words that begin with vowels have the Y sound added on the end. So for example, item starts with vowels I, then this time item, and then we add YAY. Okay, so if the first letter is vowel, then this is the Pig Latin word. And if this is the case, this is a CH. There are some letters like this, CH, GR, something like that. Then CH will be moved together. So AIR and CH, and then AY is added like this. The primary objective translating a sentence is too complicated for one method to accomplish. Therefore, we look for natural ways to decompose the solution into pieces. Translating a sentence can be decomposed into the process of translating each word. So the process of translating a word can be separated into translating words that these three parts begin with vowels and begin with consonant blends, SH, CR, TH, or CH, something like that, and begin with a single consonant. Okay, like a book, table. Okay, so we will decompose the problem like this. This is the result output of the code. So when you enter orange, then O is the vowel. So orange and YAY is added like this. And then translate another sentence. If you press Y, then the computer will receive more input. So this time green, GR should be together. So EEN and GR goes here, and then adding AY. If the sentence is chicken, then CH will be moved together. So CH will be here like this, and then AY. And Java, this time there is only one consonant, so J will be moved to the end of the word like this. Okay, so I'll show you a code for working like this. This pig Latin example shows method decomposition, and here is a class diagram for that. Pig Latin class will have only one method, main method. So pig Latin is a driver class. Pig Latin translator class will have only 4 methods. There is no member variables like that. And among 4 member method, translate method is public, and the other 3 are all private, right? So we can think that the translate method will use these 3 private methods. And actually, the translate will call translate word, and translate word methods will use these two methods. So at first, translate method receive one input. For example, this is the input. Then the translate method will change this sentence into all lowercase letters like this. And translate will divide the sentence to each word, so that we can have Latin word for hello, Latin word for word. Okay, so the Latin word for hello is this, and the Latin word for word is this one. Okay, so this is the final output. So translate will have this as input, and divide and translate word will have Latin word. And these 2 methods will be called by translate word to find pig Latin of this string. Okay. In a UML class diagram, the visibility of a variable or method can be shown using special characters, plus and minus. Public member are preceded by plus sign. Private members are preceded by the minus sign. Okay. Then let's see these 2 class files. This is a pig Latin class, and it has main method. In the main method, pig Latin translator dot translate method is called. So you can know that translate method will be static, okay, because it is called using the class name. So translate method is static, and translate method calls translate word method. Then translate word methods also must be static. And translate word method will use these 2 methods. And therefore, these methods also should be declared as static like this, okay? So at first, the main method will receive a sentence, and the sentence will pass to translate method. And translate method will receive the sentence, and this will make the sentence into lowercase letters, and then divide the sentence into words. Then one word can be passed to translate word method like this. Then translate word will receive only one word, and check that word starts with vowel or some blend characters. And according to this, the word will be transformed into pig Latin word, and then return the pig Latin word. Okay. This is a class pig Latin translator. It has 4 methods. One is translate, and the other 3 are private members. Translate word, and private begins with vowel, and private begins with blend. As you see here, these are blend characters. It means that 2 letters are all consonants. At first, translate method will be called by main. So main will pass one sentence to this method. For example, if the method receives this sentence, actually this is not a sentence. I put words for just for testing. Then translate will transform this sentence into lowercase letters. Then here the translate will divide this sentence into words. And call translate word method by passing have at first, and then pass chicken for the next time, and for the next time evening will be passed. So at first this method will receive have, okay, have, and it checks the word, the input word starts with a vowel. If it is not, it checks it starts with a blend characters. So have is not starts with vowel and does not start with blend. This else will be executed. So have becomes like this. Okay. And chicken. The next word is chicken. Chicken is blend word because starts with two consonants. So this is the result of chicken. And evening starts with a vowel. If the word starts with a vowel, then just add YAY like this. So evening becomes evening YAY like this. So trans word receives only one word and checks its start letter is vowel or some blend letters. Then according to this, translate word will create one Latin word for this input and then return it to this position. Okay. So translate another sentence. If I enter Y, then I can enter one more sentence. Then this time apple on the table. Then apple on the table. 4 words will be passed to translate word. And then this is the result. Apple starts with a vowel, so this is the result. On also starts with a vowel, so on YAY. The is the blend word, right? So E and TH becomes the last part, and then adding AY like this. Okay, so I think you can understand this code. So the important thing of this code is to see how decompose this program code. Okay, so if you write code like this, then it is more understandable. It is more readable by others. Okay, so this is a very good example for that. This is a main method for Pig Latin. In main, there is only two important things. One is that the main calls this method. So the sentence will pass to the translate, then translate method will have Pig Latin result of this sentence. And while looping, the main method will ask the user to more sentences like this. I think you can understand this one. Okay, now I'm going to explain objects as parameters. This is another important issue related to method design, involves parameter passing. There are two ways. There are two ways of parameter passing in Java. One is pass by value, and the other is pass by reference. You have already known this one. A copy of the actual parameter, the value passed in, is stored into the formal parameter in the method header. Up to now, our method works using pass by value way, and pass by reference is when an object is passed to a method, the actual parameter and the formal parameter become aliases of each other. I will explain more about this one. Before explaining pass by object, I will explain pass by value one more time. This is the example from the chapter 4. In main, at first, the computer will receive two inputs from the user. So two integer inputs, one is data 1 and the other is data 2. And data 1 and data 2 are passed to addition method. And then the program control goes to addition. Addition method will return the sum of two integers. Okay, this is pretty easy code. And the difference method will receive two inputs and then return the difference, the subtraction result of these two numbers. So at first data 1 here, at first data 1 and data 2 are received like this. So I input 77 and 53, then data 1 will have 77 and data 2 is 53. Then in addition, data 1 and data 2 will be passed to the addition. Then at this moment, X and Y are created in addition method area. This is the addition method area. So 77 will be copied to X. Will be copied to X like this. And 53 is copied to Y like this. Okay. So this means that addition method will create separate variable. Okay, separate variable like this and then copy the value. And into sum will be created here. Then the sum is 77 plus 53. So 130 will be stored in sum. And sum is returned to this position. Okay, so result 1 is created in main part. Then 130 will be stored in result 1 like this. And here in difference method, data 1 and data 2 will be received. So here difference x and y will be created here like this, and then copy values from main. Okay, and then diff will be created here, and x minus y 77 minus 53 will be stored in diff. That is 24. Then return diff. So diff will be stored in result 2 like this. Okay, so I think you understand this one. The important part is that when main calls method and pass by value, passing value like this, then separate area, in the separate area, the variable will be created like this. In separate area, the variable will be created like this. Okay, so if in the addition, if the value x is changed, it does not affect the data 1. Okay, this is completely separate variables, this one and this one. Okay, so this is pass by value example. Let me explain pass by reference. What a method does with a parameter may or may not have a permanent effect. Note the difference between change the internal state of an object versus changing which object a reference points to. I will explain this using example, and actually we will see this example from the textbook. But at first I will provide this example, a simple one, for your understanding. This is class child info. It has two private members, name and age, and it has constructor, set age, get age, toString method like this. So you understand this one. And in another class, this is the driver class to use child info class object. In this child info test class, there is a main method, and main method will call change age method. Okay, then I will execute main method, and I will show the memory while executing main method. At first, child object is created, and the initial value is Jack and 10. So child object will be created like this in the main part. Okay, so this is the object reference variable. So there is an address to this object. This is a real object. Okay, so it has the actual address of this object. So if we print out this child, then Jack is 10 years old will be printed out. Next, change age is called. Here, change age method is called. And object is passed to here. Okay, object is passed to here. Since the child is child info class type, we must write child info here. Okay, then CI will receive this child information. So CI will be created in this area. So CI will be created here. Okay, but this time CI only copied this value. Okay, so CI will point the same object as child. This is a call by reference. Okay, the object is not copied, just reference value is copied. So finally, these two variables will share one object like this. This is a call by reference. So here, if we call set ci.setAge, then this method will be called, and 12 is here. So 12 is assigned to this age. This time, here this. Since CI is this, right? So CI calls set age. This time CI is this. So actually the age is changed into 12 like this. So after execution of this method, in this print statement, 12 is printed out. So as you see here, this object is created in main, right? But other method change age can access this object and change the value like this. Then even if child does not change the content of the object, child will have the new value 12 here. Okay, this is the call by reference. This is an example from the textbook. There are three classes. One is num and parameter modifier, and in the next page, parameter tester. Okay, parameter tester, and here num class has one private value and one constructor and send method and toString method. So this is pretty simple class, so I think you understand this one. And let's see parameter modifier class. It has only one method, change values, and it has three parameters: primitive data f1, and these two are objects, right? So here pass by value will be occurred, and here pass by reference will be occurred. Okay, so right after calling this method, it prints out the original value of f1, f2, f3 like this. So this is tab key, you know. Okay, this is tab. Okay, and after that, it changed the value of f1, f2, and f3. So f1 becomes 999, and f2 dot set value 888, and here f3 will have a new object. F3 will have a new object. Okay, please remember this one. And after change these three values, the method will print out the result again. Okay, and let's see the main code. This is the main code. Main code will create one object called modifier. Then modifier will call change value method here. Okay, and here there are three data: primitive data 111 and two num objects. And this is just print out. Okay, before calling change values will be printed out, And A1, this is tab key, A1, A2, A3 are printed out like this. And the value of A1, value of A2, value of A3 is printed out. So 111, 222, 333 are printed out like this. And change values method is called. Then this method will at first print out the received parameters. Okay, so the result is the same. Result is the same as this. Okay, and actually these are print out by the method. Print out by the method. And this part will be printed out from the main part. Okay, from the main part. Okay, so let's see method again. And after printing out, it will change the values of F1 and F2 and F3. So F1 becomes 999 and F2 888, and here F3 new object. Okay, so I'll show you the memory status while executing this main code. Okay, so at first main is like this. A1 is 111 and A2 has this object and A3 has this object. Okay, then upon calling this method, F1 will have 111. Okay, it's just A1 is copied to F1, and F2 is an object reference variable. So this value will be copied here. Okay, so F2 actually point out this object, and F3 also have this value. So F3 will point out 333. So it's okay. Okay, I think we'll understand this one. Then the method changed the value to 999 and F2 dot set value 888. Okay. And then F3 is assigned by new object. This one. This time F3 will point to this new one. Okay, so this is the result memory of after calling the method. And after calling the method, we print out the final values in the memory. Then as you see here, after calling the change value, A1 is still 111. Okay, because there is a copy. Copy is created, and then F1 is a copy. So 999 is in F1 but not A1. And A2 becomes 888 because this reference variable will share this object together. Okay, so 888 is printed out, and finally A3 is printed out 333. Okay, because F3 does not affect this object. Okay, so if you see this, this part, this F1 and this A1 is not connected to each other. Okay, this is pass by value, and these are the same. Okay, because F2 and A2 share this object together. Okay, this is called by reference. This is called by value. This is called by reference. And this is different stuff, because F3 point to a new object. Okay, so I think you can understand this one. So if you don't understand right now, then please try to draw the memory status like this. Then I think you can understand easily. This is very important in computer science.